Yeah, it's really loud now. You can see my microphone. All right. So the gradient is change in y divided by the change in x. Also, how did we call that? So the change in I we called, that's the rise over run. Okay. So rise over run is what we were doing. Right. And we drew the track. So this line here, what's the gradient of this little line segment they've put there? 2 over 4. 2 over 4, which simplifies to 1 over 2, or 0.5. Okay. All right. So we do have gradient knowledge like that. We also know that we have a positive gradient if it's going up. We have a negative gradient if we're coming down. So we've always got, they've done it a little bit differently. I would say the run is always left to right. Okay, so left to right. So that's always a positive number. Okay, but the rise in this case, this is going up. So we have a rise, which is positive, but this one is a down. So the rise is negative. That's why we get a negative gradient. Okay. We've also discussed that if you have a steep gradient or you have a shallower gradient, the numbers will be different, right? So steeper gradient will have a higher number. So what's the gradient of this one again? 2. So in this case, we'll call it m equals 2. This one, not so steep, and it's m equals 0.5, or 1 over 2. Are those two lines perpendicular? Good, right? You can see they're not perpendicular, but you can also tell it does look like it, doesn't it? The numbers are flipped, like you were saying, but it's not negative. So we've done all that. That's a bit of a recap. Now, I think next is the two. Make life interesting, that's all. So what we've now got is two other sets of lines to be aware of. So we've got horizontal lines. So that's like if you imagine walking along a road compared to walking up a hill or down a hill. So it makes sense that a horizontal line is a gradient which is 0. And that's because if you, it makes perfect sense, because if I did rise over run here, what's the rise? 0. What's the run? Well, 4 in this case, but infinitely, yeah? So we have 0 divided by something. The answer is always 0. Okay? So if I've got a horizontal line, that's the new thing now, all right? The gradient is 0. So it's just a completely flat, level line. Now, bit different if the line is vertical. And what we say, if it's vertical, the gradient is actually undefined. Okay, why is that? Okay, because what's the rise?
There's no rise.
Well, the rise in this case is the as much as you want, but what's the run? 0. There's no run. So you must have encountered this before. If you divide something by 0, the answer is not 0. You get a maths error on your calculator, and the true way of saying it is it's undefined, because we have no way of processing it. It's not really you can't do it is not a good answer these days. It's like it's an undefined value. We have no way of expressing it. It's like saying you take something and you divide it into 0 pieces. Well, something divided into no pieces is not nothing, because you've still got the something, right? So that's why we say it's undefined, because if you take a cake and you divide it between no people, you've still got the cake. You just have no way of sharing it. There's no process to do it. So it's undefined. So horizontal line, gradient is 0. Vertical line, gradient is undefined, not infinite. Undefined. Okay? So then we look at, well, what are the equations of lines that look like that? Okay? So got this worksheet, right? We've got to draw the lines, and you might think, actually, I don't recognize the form here, because what are we not seeing in these equations here? There's no y. It's not of the form y equals mx plus c.
It just equals 1 and
Okay, so almost. So what we mean by a line like when we say x equals 1 is because the coordinates on that line, because remember, a line is not what? Remember I said a line is not a line. What is it? Sort of like a line is not just a line that we drew, it's an infinite number of points, coordinates, yeah? So what are we saying about a line which has an equation x equals 1? Well, we're saying that the x coordinate is always 1. What do we know about the y coordinate? Nothing.
You don't know it.
Don't know. But what that means is that it doesn't matter what the y coordinate, the x coordinate will always be 1. So if I had to draw a point on this set of axes for a coordinate that I'm allowed, where would you put it? So I've got to pick a coordinate where the x coordinate is 1. Where would you put one? A coordinate has 2 numbers. 1, 0, which is here, yeah? So 1, 0 is allowed. So we've got x equals 1. Could you give me any other coordinates that are allowed? 1, 1, 1, 2, 1, 4, 1, anything, yeah? So basically, if I start putting the coordinates in, can I go in between? Yeah? So what's it going to look like if I... A straight line, not just straight, but... Come on. Oh, it's because my computer's going slow. It doesn't like it. Done in sections. Okay, if I draw a straight line, I go down. It is a vertical line, yeah? So x equals 1 looks like that. So what do you think x equals 4 looks like? Same but where 4 is. So come on, computer. Yeah. So x, you can see it should be on the 4, but for whatever reason my computer's not like it. X equals 4 like that. So you can probably finish the other 2 lines off. So we've gone through all of these. We've plotted them all in. Like x equals -2. Every coordinate on that line, it doesn't matter what the y coordinate is. That's why there's no reference to y in this equation. But all of them are all vertical lines. So, moving on to these questions then, A, B, and C. Hopefully you can tell me what the equations of those lines are now. I'll let you do it. Okay, you're probably done now. So what'd you get for this one? First one? X equals 2. This one's x equals
X equals 3.
negative 3.
X equals negative.
X equals negative 2.5. Okay, right. So thinking about that, we move on to some y equals. Now, I'm pretty sure that you will be able to think, right, I've got y equals sorted now. That's probably quite easy. So what do you think a y equals 2 line would look like?
Horizontal to the point or the rubber point.
Yep. So we've got a y equals 2 is a line where all the y coordinates are 2 and we don't care what the x coordinate is. Okay. So that would be the y equals 2. Every coordinate on that line is going to be something 2. So the y coordinate is always 2. It doesn't matter what the x coordinate is. So you can rattle through the next 6 questions, no problem, I reckon. Quick one then. What about this question here then? From the box, choose any coordinates that lie on y equals 2. So which ones?
I just circled the.
So I know that this one,
Yeah, I circled that.
so negative 1, 2. Is there any others? No. So which one? X equals 4. Is this one?
4?
3, 4. No.
Oh no, sorry.
It's
4,
only this one is
1.
4, negative 1. Any others? No. X equals 3. 3, 4. Y equals negative 1.
4 is negative.
4, negative. Now you'll notice, look, that coordinate is on both of those lines. The x-axis, well, that's when y equals 0. So 6, 0, yeah. And the y-axis, well, that's when x equals 0. So 0, 5. Okay. Okay, I gave you perpendicular lines. How do you feel about the vertical horizontal lines now? All right? All good? So this line, straight line, so y equals mx plus c. We've done rise over run. So we have a run of 2. The rise is negative 1, so we're actually dropping. So that gives us a gradient of negative 1 over 2. And then the y-intercept, it's so easy from a graph. This is why graphs are quite nice. Read the 3 off the graph and just put the plus 3. So we've got y equals 1/2 x plus 3. That's the equation of the line. Happy with that? Yeah. However, they've told us that the equation of the line is actually x plus 2y equals 6. Right? And what we need to know is whether those two things are equivalent, which they are, but how to get there. So if we look at the next part of this question, it says rearrange the equation x plus 2y equals 6 to make y the subject. So we know we need it to be minus 1/2 x plus 3. That's making y the subject. But the question is, how could we do that algebraically? And you have done this before. So how would you do it? Take away 3. Oh no, we've got to start with this. So we're starting with x plus 2y equals 6. How do we get from this to this?
You take away 6, x plus 2y plus 6 equals 0.
You can do that,
Divide by 2.
but the thing is, did that help me? I want to get the y on its own. You put everything with the y.
Everyone wants it. Divide by 2.
Okay,
And then you
so right, let me just be, I'm going to be a little bit careful here, but you're fine to say that. If we divide it by 2, what do we get?
x plus y.
Actually, we don't. I'm going to give you this one. I'm going to give you this one. Divide by 2, divide by 2. But what did you just ignore?
Yeah.
The x. You have to divide everything by 2 if you're going to do that. So that would be x also divided by 2. Right? Now what would you do? I just want y equals. So yeah, but what? In what way? So if we minus it, gets rid of it on this side, and that leaves me with y equals 3 minus x over 2. Now, is that the same as this?
Yeah.
It is, isn't it? Because y equals, what's x over 2? It's, if you were to say it as a different way in words, is it? It's so minus 1 over 2 x. X divided by 2 is the same as half of x. And we've got minus half of x. And remember, if we have it this way round, we could, Toby was doing a lot of this, which is we could say, just take this bit and write it on the front. So minus a half x plus 3, which is what we got. So there's another smiley face for you. All right. So part B says, write down the gradient of the line with the equation what x plus 2y equals 6. What would you tell me? Yeah, negative a half. Now, this leads us to an important little sort of understanding, guys. This is fundamental to this part, which is this form of the equation, y equals mx plus c, has a particular name which is called gradient intercept form. Why do you think it's called gradient intercept form?
Where the gradient gets intercepted.
Nope.
Or
What can I use it for? What can I use half x plus 3 to find? So what's the half? That's the gradient. What's the plus 3? It's the y-intercept. So can you see why it's called gradient intercept form? Because that form tells me the gradient intercept. However, this is a different form of the equation. So the name for this form is standard form. What can I not tell immediately from standard form? Well, I can. I've got an equation. But no, we could do. Well, what is it not to link back to what we've just said about the other form? What does standard form not tell me? The gradient and the intercept. what people do is they go, oh, gradient is just the number in front of the x. Yeah? They don't really understand properly. So they would write down the gradient is 1. But we know the gradient is actually negative 1 over 2. All right? So that's a very common mistake. 1 is not... Write down the gradient of the line. Well, if it's in standard form, you need to do some working out. You can't just write the gradient. Okay?
You have to show like the second part of our working out and show how we got to why we did
What do you mean by...
You can work out what the gradient intercept one is about, like having to
Because we had the graph.
yeah.
Yeah, so
the graph, you have
okay, it's a good question. So if I was given this question in an exam and it said to me, I don't know why it's doing that, it said work out y equals make y the subject, and you wanted to do exactly what we did, that's fine. That would get you full marks. Yeah. You're not always going to get given the graph though. So to be able to do what we did here is important. But you're right. If there's a graph and you don't need to do whatever's quickest. All right. Okay. Let's just check. Kind of goes in line with what we were just doing. Write down the equation of the line which is parallel to this line, but passes through the point 0.07. How would you do that? Well, again, you know this word.
gradient.
Okay, so we've got same gradient. That should get second nature to you. You should be all, like, as soon as it says parallel, so same gradient. So what was the gradient again? Negative 1. So m has to be negative 1 over 2. So although we've got the equation in this form, we could use the other equation, which was y equals negative a half x plus 3. But we want that goes through 0.7. So we are actually going to have y equals negative 1 over 2x plus c. But, Toby, don't forget that if I've got 0.7, it's just the 7. Yeah. We could have dealt, you were about to start 7 equals a half type, but which would have been absolutely fine. So that is, now, although it's not asked for in this question, how could we now go to standard form? Any ideas? From this back to something that looks like that. So we've got to do the reverse of the rearranging. What would you do? How'd you do it?
Well, it's the same gradient, so it would just be 2y.
So if I did the first thing, if I multiplied by 2, I would get 2y's equals minus x plus 14. I don't think this is what you did. I think you did a bit more of a make sense, common sense approach, didn't you? You kind of used the other one. But now I would just add x to both sides and get 2y plus x equals 14, or put it in order, x plus 2y equals 14. So that's something that you... Now, standard form, you'll notice, does not have fractions. So we always have to multiply out to get rid of fractions.